Since the first telescopes pointed to the night sky, Mars has always sparked our curiosity. With its reddish hue and mysterious landscapes, this planet has been the target of studies, speculations, and even science fiction stories. But it was only in recent decades that we began to understand how truly incredible Mars really is. In 2015, NASA made an announcement that reverberated around the world. There was concrete evidence of liquid water on the surface of Mars. This revelation was not just a scientific milestone, but also an invitation to rethink everything we knew about the universe. But why was this discovery so impactful? After all, water is something we easily find on Earth, right? Yes, but in the context of space, finding liquid water is like discovering a hidden treasure. It is essential for life as we know it, and its presence could indicate potential extraterrestrial habitats. To better understand this revelation, we need to go back to basics. Mars is a cold planet with average temperatures below zero. Additionally, its thin and rarefied atmosphere makes it difficult to maintain water in liquid form. So, how is it possible for water to exist there? The answer lies in a combination of factors. Scientists discovered that the water on Mars is not exactly the same as what we see in rivers and lakes on Earth. It contains high levels of salts, which lower its freezing point and allow it to remain liquid even under extreme conditions. Another important detail is that this water does not flow freely across the Martian surface. Instead, it appears seasonally in the form of flows that emerge during the Martian summer. These flows are called recurring slope lineae, RSL. The RSL were detected by space probes such as the Mars Reconnaissance Orbiter. These dark streaks appear on steep slopes and seem to expand as temperatures rise. When winter arrives, they disappear again. But how did scientists confirm that these streaks were caused by water? They used advanced spectroscopy techniques, which analyzed the chemical composition of materials from a distance. By examining the collected data, they identified hydrated minerals in the regions where the RSL occurred. The presence of these minerals was definitive proof. They can only form in the presence of water, confirming that Mars is not just a dry and inhospitable desert. This discovery generated enormous enthusiasm in the scientific community. Imagine thinking that Mars, billions of years ago, might have been much more similar to Earth than we imagined. Perhaps it even harbored microbial life forms. Of course, many questions remain unanswered. For example, where does this water come from? Does it emerge from underground reservoirs? Or is it the result of chemical processes that release water vapor from the atmosphere? These are questions that continue to be investigated. Moreover, the discovery of water on Mars also has practical implications for future human missions. Water is essential not only to sustain life but also to produce fuel and oxygen. This means explorers could use the planet's own resources to survive. Thus, Mars went from being a distant target to becoming a tangible goal. Space agencies around the world are planning crewed missions for the coming decades. And who knows? Maybe one day we will step onto the red planet and witness these water flows with our own eyes. Now that we know that Mars has liquid water, it's time to dive deeper into the process that led scientists to this discovery. After all, how was it possible to detect something so crucial on such a distant planet? To understand this, we need to talk about the technological tools used by space agencies. Space probes, for example, are true machines of the future. They are equipped with instruments capable of analyzing the Martian surface without touching it. One of the protagonists of this story is the Mars Reconnaissance Orbiter MRO, a NASA probe launched in 2005. The MRO has orbited Mars since 2006 and has played a fundamental role in exploring the red planet. One of the main tools of the MRO is the Imaging Spectrometer CRISM, Compact Reconnaissance Imaging Spectrometer for Mars. This instrument acts as a chemical detector that analyzes the light reflected by the Martian surface to identify specific compounds. When scientists examined CRISM data in the areas where recurring slope lineae appeared, they noticed the presence of hydrated minerals. These minerals can only form when there is interaction between rocks and liquid water. In addition to CRISM, other high-resolution cameras on the MRO were also essential. They allowed for observing seasonal changes on Martian slopes, reinforcing the hypothesis of water flows. But since images alone were not enough to confirm the presence of water, scientists combined visual data with spectroscopic analyses. This multidisciplinary approach was crucial to validate the discovery. Another important mission was Mars Express, from the European Space Agency, ESA. Launched in 2003, it helped map vast regions of the planet and found evidence of underground glaciers, suggesting that Mars may still have large reserves of frozen water. These underground glaciers are especially interesting because they could be feeding the seasonal flows observed on the surface. However, there is no absolute certainty about this yet, and more research is needed. It's worth noting that the search for water on Mars didn't begin with these recent missions. Since the 1970s, probes like Viking had already been collecting information about the planet's soil and atmosphere, although without finding direct evidence of liquid water. With advancements in technology, however, the tools available today are much more precise. This allows us not only to detect water but also to study its properties and origin in impressive detail. Another fascinating point is that the water on Mars seems to be distributed unevenly. Some regions show clear signs of hydrological activity, while others appear completely dry. This suggests that the water cycle on Mars may be very different from what we see on Earth. Additionally, the presence of salts in Martian water, as mentioned earlier, is a determining factor. These salts lower the freezing point of water, allowing it to remain liquid at extremely low temperatures. However, the high concentration of salts also brings challenges. Extremely salty water can be lethal to many known life forms. This raises another intriguing question. If life exists on Mars, has it evolved to tolerate such hostile environments? Now that we've already understood how water was detected on Mars, it's time to explore one of the most fascinating questions about the red planet. Could this water harbor life? This question has intrigued scientists and curious minds for decades. After all, on Earth, where there is water, there is generally life. From the depths of oceans to the driest deserts, organisms can survive in extreme conditions as long as they have access to this essential resource. On Mars, however, the situation is a bit different. The water found there isn't exactly the same as on Earth. Besides being salty, it is subject to extremely low temperatures and intense radiation, factors that make the existence of life as we know it difficult. Even so, scientists are optimistic. They know that microbial organisms can be incredibly resilient. On Earth, for example, there are organisms called extremophiles that thrive in hostile environments, such as hot springs, glaciers, and even underground mines. This raises the possibility that similar life forms may have evolved on Mars. Perhaps they are able to tolerate highly concentrated salts or protect themselves from radiation using layers of ice or rocks. Another important point is that Mars wasn't always as inhospitable as it is today. Billions of years ago, the planet had a thicker atmosphere and milder temperatures, allowing rivers, lakes, and perhaps even oceans to flow across its surface. During this ancient period, known as the Noachian, Mars might have been a more favorable environment for life. Some theories suggest that microorganisms may have emerged during this time and, who knows, might still persist in underground refuges. To investigate this, space missions have focused on searching for signs of past or present life. For example, the Perseverance rover, launched by NASA in 2020, is collecting soil and rock samples that may contain traces of biological activity. The goal of these missions is not only to find life but also to understand how Mars evolved over time. Discovering why the planet lost its atmosphere and liquid water could help us predict similar scenarios here on Earth. Moreover, the search for extraterrestrial life goes beyond Mars. It helps us answer fundamental questions about the universe. If we find life on another planet, even if it's microbial, it would mean that life is not exclusive to Earth. Imagine the philosophical and scientific impact of such a discovery. Knowing that we are not alone in the cosmos would completely change our perspective on humanity's place in the universe. However, finding evidence of life won't be easy. Scientists need to ensure that any detected signal is truly of biological origin and not the result of natural chemical processes. For this, they use rigorous criteria. One example is the presence of complex organic molecules, which could be indicators of biological activity. But these molecules can also form without the intervention of life, so the analysis needs to be careful. Despite the challenges, each new discovery brings us closer to an answer. The water on Mars is a big step in that direction, as it suggests that the planet may have had the necessary conditions to sustain life. Now that we already understand how water was detected on Mars, it's time to explore one of the most fascinating questions about the red planet. Could this water harbor life? This question has intrigued scientists and curious minds for decades. On Earth, where there is water, there is usually life. From ocean depths to arid deserts, organisms can survive in extreme conditions as long as they have access to this essential resource. On Mars, however, the situation is slightly different. The water found there isn't exactly like Earth's. Besides being salty, it's exposed to extremely low temperatures and intense radiation, making it challenging for life as we know it to exist. Even so, scientists remain optimistic. They know microbial organisms can be incredibly resilient. On Earth, extremophiles thrive in harsh environments like hot springs, glaciers, and underground mines. This raises the possibility that similar life forms may have evolved on Mars, potentially tolerating concentrated salts or shielding themselves from radiation using ice or rocks. Another key point is that Mars wasn't always as inhospitable as it is today. Billions of years ago, during the Noachian period, the planet likely had a thicker atmosphere and milder temperatures, enabling rivers, lakes, and possibly oceans to exist. This raises the tantalizing prospect that microbial life may have arisen during this era and could still persist in underground refuges. To investigate this, space missions like NASA's Perseverance rover are collecting soil and rock samples that might contain traces of biological activity. Beyond Mars, the search for extraterrestrial life addresses profound questions about humanity's place in the cosmos. Finding even microbial life elsewhere would reshape our understanding of life's uniqueness. However, detecting such evidence requires meticulous analysis to distinguish biological signals from natural chemical processes. Each discovery brings us closer to answering one of humanity's greatest questions. Are we alone? The discovery of water on Mars didn't just fuel dreams of extraterrestrial life, but also propelled ambitious plans to colonize the red planet. Imagine living on another world. While it sounds like science fiction, it's getting closer to becoming reality. The presence of water is a crucial factor for any human mission to Mars. It's essential for drinking, of course, but it also plays vital roles in producing food, oxygen, and even rocket fuel. For example, water electrolysis can separate its components, hydrogen and oxygen. Oxygen can be used for breathing, while hydrogen can be combined with carbon dioxide from the Martian atmosphere to produce methane, an efficient fuel. This means astronauts could use the planet's own resources to sustain their stay, drastically reducing the amount of supplies they'd need to transport from Earth. This concept is called in situ resource utilization, ISRU. Additionally, water could be used to create habitats protected against cosmic and solar radiation, one of the biggest threats to human health on Mars. Underground structures or those covered by layers of ice could serve as safe shelters. However, there are enormous challenges to overcome before we can think about living on Mars. First, the water found there isn't exactly ready for use. The highly concentrated salts would need to be removed, and this process requires advanced technology and energy. Another issue is the location of the water. Much of it seems to be concentrated in specific regions, such as underground glaciers at the poles or seasonal flows on equatorial slopes. This means the first colonizers would need to carefully choose where to land. Despite these challenges, various space agencies and private companies are heavily investing in developing technologies to explore and utilize Martian water. NASA, for example, has projects focused on testing water purification systems in extreme environments. SpaceX, led by Elon Musk, is also working on plans to send humans to Mars. Its vision includes creating a self-sustaining city on the planet, where water would be a central resource. However, colonizing Mars goes beyond technology. Ethical and environmental questions must be considered. Deliberately altering the Martian environment to make it more habitable, a process called terraforming, sparks intense debate. Some argue that we should preserve Mars in its natural state, especially if there's a chance of finding microbial life. Others believe terraforming would be necessary to ensure humanity's long-term survival. Regardless of which side of the debate you're on, one thing is certain: water will be a key piece in any colonization effort. Without it, our dreams of living on Mars would remain just that, dreams. Currently, missions like Artemis, led by NASA, and research in analogous environments on Earth are helping pave the way for future crewed expeditions. These efforts include simulations of extracting and using local resources, such as water. As we move forward, it becomes clear that Mars isn't just a distant destination but a living laboratory to test our limits as a species. Every step toward the red planet teaches us something new about ourselves and our place in the universe. Dreaming of sending humans to Mars is exciting, but turning that dream into reality involves overcoming enormous challenges. After all, we're talking about a journey of millions of kilometers in a hostile and unknown environment. The first major challenge is the distance. Mars is, on average, about 225 million kilometers from Earth. Depending on the position of the planets, a trip can take between 6 and 9 months. This means astronauts will need enough supplies to survive for the entire duration. Additionally, once on Mars, astronauts will face another problem: communication with Earth. Due to the enormous distance, messages can take up to 20 minutes to reach their destination. This latency makes real-time conversation impossible, requiring explorers to be extremely self-reliant. Another critical obstacle is cosmic radiation. Outside the protection of Earth's magnetic field, astronauts will be exposed to dangerous levels of solar and cosmic radiation. This increases the risk of cancer and other long-term health issues. To mitigate these risks, scientists are developing new shielding technologies for spacecraft and habitats. Special materials such as hydrogels or layers of water can help absorb some of the radiation, protecting the crew. Microgravity is also a concern. During the months of travel, astronauts will be exposed to reduced gravity conditions which can weaken muscles and bones. Regular exercise and specialized equipment will be essential to minimize these effects. Upon arriving on Mars, the challenges don't stop. The Martian atmosphere is composed mainly of carbon dioxide and is extremely thin, making it difficult to safely land spacecraft. Unlike Earth, where a dense atmosphere aids braking, on Mars it will be necessary to use rockets and giant parachutes. Another important point is the extreme climate. Temperatures on Mars can drop to -80 degrees Celsius or lower during the night. Equipment and spacesuits will need to be designed to withstand these conditions without compromising the comfort and safety of the astronauts. Moreover, Martian dust is a silent enemy. It's extremely fine and abrasive, capable of damaging equipment and electronic systems. Not to mention it can be toxic if inhaled, requiring extra care in constructing airtight habitats. Human psychology also comes into play. Being isolated for long periods, far from home and in such a hostile environment, can deeply affect the mental well-being of astronauts. Training programs and psychological support will be fundamental. Despite these challenges, technology is rapidly evolving to make the mission possible. For example, prototypes of spacecraft like SpaceX's Starship are being tested to ensure they can transport humans safely. Additionally, simulations in analogous environments, such as Hawaii's desert or remote stations in Antarctica, help prepare astronauts for the extreme conditions they'll encounter on Mars. Another important advancement is the development of resource recycling systems. Water, air, and food will need to be continuously recycled to sustain the crew. Projects like NASA's Life Support System are already being successfully tested. Finally, international collaboration will be crucial. No single space agency or private company can accomplish this mission alone. Governments, businesses, and scientific institutions will need to work together to share knowledge and resources. The idea of exploring Mars and finding water on the red planet fascinates not only scientists but also fuels the imagination of writers, filmmakers, and artists across generations. From early reports of Martian canals to modern sci-fi films, Mars has always held a special place in pop culture. In the early 20th century, astronomer Percival Lowell popularized the idea that Mars was covered by a network of canals built by an advanced civilization. Although this theory was debunked, It inspired countless stories and literary works about intelligent life on the planet. One of the most iconic examples is the Barsoom book series, written by Edgar Rice Burroughs in the 1910s. In it, Mars, or Barsoom, as it's called by its inhabitants, is depicted as an exotic world full of ancient civilizations, warriors, and breathtaking landscapes. Later, in the 1950s, films like The War of the Worlds brought Mars to the big screen. These productions often portrayed the planet as home to hostile alien invaders, reflecting Cold War fears and political tensions of the time. With the advancement of space exploration in the following decades, the portrayal of Mars in pop culture began to shift. Instead of being a scary place, it started to be seen as a possible destination for humanity. Movies like Red Planet, 2000, and Mission to Mars, 2000, explored themes of human colonization and the search for water as an essential resource. In the last decade, productions like The Martian, 2015, based on Andy Weir's bestseller, perfectly captured the scientific optimism surrounding Mars. The movie shows how human ingenuity and the presence of water can turn seemingly impossible challenges into opportunities. TV series have also joined the Martian wave. The Expanse, for example, portrays Mars as a developing planet where human colonies struggle to survive and thrive. Water plays a central role in this scenario, serving both as a strategic resource and a source of conflict. Additionally, games like Surviving Mars allow players to experience the challenges of colonizing Mars. In them, managing resources like water, energy, and food is essential to ensure the colony's survival. These popular representations not only entertain but also help disseminate knowledge about Mars and its unique characteristics. They make complex concepts like the importance of liquid water accessible to the general public. Another interesting aspect is how pop culture influences public interest in space exploration. Successful movies and series often spark curiosity about real missions, such as those conducted by NASA or SpaceX. For example, after the release of The Martian, there was a significant increase in online searches about Mars and space programs. This demonstrates the power of storytelling to inspire people to engage with science and technology. However, not all portrayals of Mars in pop culture are accurate. Some oversimplify the challenges of space exploration or create unrealistic expectations about the ease of living on the red planet. It's important to balance entertainment with fact-based information. Even so, these stories fulfill a vital role. They expand our horizons and make us dream of a better future. By imagining new worlds and unexplored possibilities, they remind us of humanity's unlimited potential. Today, with the discovery of water on Mars and technological advancements, these dreams are closer to becoming reality. Pop culture continues to evolve, reflecting our progress and hopes for the future. Mars has always been fertile ground for conspiracy theories and myths. From early reports of Martian canals to modern images captured by space probes, the red planet seems to ignite our imagination and sometimes our fears. One of the oldest and most famous theories is the idea that Mars harbors an advanced civilization. This belief gained traction in the 19th century when Italian astronomer Giovanni Schiaparelli reported observing canals, on the planet's surface. Although he used the term in a scientific context, many interpreted it as evidence of alien engineering. This interpretation led to fantastic narratives, such as the idea that Martians built vast irrigation networks to transport water from their icy poles to habitable regions. These stories were widely disseminated at the time, fueling both curiosity and speculation. With advancements in technology and the deployment of probes to Mars, these theories were debunked. However, new conspiracies emerged. One of the most popular is the supposed existence of artificial structures on the Martian surface, such as pyramids or giant faces carved into stone. The most famous example is the so-called face on Mars, photographed by the Viking 1 probe in 1976. The image showed a rock formation that vaguely resembled a human face, leading some to believe it was a sculpture left by an ancient Martian civilization. Later, high-resolution images captured by other missions revealed that the face was merely an optical illusion created by shadows and irregular relief. Even so, the idea persisted among conspiracy theory enthusiasts, who claim that the evidence has been covered up by space agencies. Another popular theory is that intelligent life exists on Mars but is being deliberately hidden from the public. Some believe that NASA and other organizations are concealing evidence of alien spacecraft or extraterrestrial bases on the red planet. These theories often rely on misinterpretations of photos taken by space probes. Natural formations, shadows, and visual artifacts are frequently misinterpreted as artificial objects or signs of alien activity. Moreover, some believe that Mars has already been colonized by humans or that secret missions have already sent astronauts to the planet. These stories often circulate on unreliable websites and depend on anonymous testimonies or weak evidence. Despite being scientifically unfounded, these theories continue to capture the public's imagination. They reflect our desire to find something extraordinary in the cosmos, something that challenges our understanding of the universe. Interestingly, some of these ideas also have roots in social and political concerns. For example, during the Cold War, rumors about alien invasions or secret bases were often used as metaphors for global tensions. Today, with the growing popularity of social media, these theories spread even faster. Videos and posts about shocking discoveries on Mars often go viral, even without any scientific basis. However, it's not all negative. These theories also help keep public fascination with Mars and space exploration alive. They encourage debates and questioning, even if their conclusions aren't always accurate. For scientists and educators, these conspiracies represent an opportunity to teach critical thinking and promote scientific literacy. By explaining how evidence is collected and analyzed, they can help people distinguish facts from fiction. The discovery of water on Mars not only changed our understanding of the planet, but also opened the door to a new era of scientific exploration. Now, more than ever, we are determined to unravel the mysteries of the red planet. One of the most promising areas of research is the search for microbial life. As we've discussed, the presence of water significantly increases the chances of finding life forms, even if they are tiny and primitive. For this, new missions are being planned with more advanced instruments. For example, the Perseverance rover, currently exploring Jezero crater, is collecting soil and rock samples that may contain traces of ancient biological activity. These samples will be stored in special tubes and left on the Martian surface to be collected by future missions. NASA and the European Space Agency, ESA, are working together on the Mars Sample Return Project, which aims to bring these samples back to Earth for detailed analysis. Additionally, other probes and rovers are being designed to explore specific regions of Mars. Areas like underground glaciers or seasonal water flows are priority targets, as they may harbor environments more conducive to life. Another important area of research is the study of Mars' climate. Understanding how Mars lost its atmosphere and liquid water can help us predict similar scenarios on Earth, especially as we face climate change here. For this, missions like the Trace Gas Orbiter, TGO, part of the ExoMars program, are analyzing rare gases in Mars' atmosphere. This data can reveal clues about chemical and physical processes that shaped the planet over billions of years. Emerging technologies are also revolutionizing the way we study Mars. Space drones, like Ingenuity, the first helicopter to fly on another planet, allow us to explore terrain inaccessible to traditional rovers. The success of Ingenuity demonstrates that aerial vehicles can be used to quickly map large areas and access remote regions. This opens new possibilities for investigating locations previously considered unreachable. Moreover, space telescopes like the James Webb are contributing to our understanding of Mars. Although its primary focus is observing distant galaxies, it can also provide valuable information about atmospheric composition and temperature conditions on the planet. In the near future, international collaboration will be even more crucial. Countries like China, the United Arab Emirates, and India have already launched their own Mars missions, demonstrating that space exploration is no longer the exclusive domain of traditional superpowers. This diversity of efforts enriches scientific research, as different agencies bring unique approaches and technologies. Together, they can accelerate our progress toward fundamental answers about Mars. Private companies are also entering the space race. SpaceX, for example, is developing the Starship, a spacecraft designed to transport humans to Mars. If successful, This initiative could transform the exploration of the red planet into an everyday reality. Finally, scientific research on Mars is not limited to the planet itself. It also helps us better understand the solar system and the universe as a whole. By studying Mars, we learn about planetary formation, climate evolution, and even the possibility of extraterrestrial life. Exploring Mars is not just about uncovering the secrets of the red planet. It also has the power to inspire millions of people around the world, especially young people, who may feel motivated to pursue careers in science, technology, engineering, and mathematics, STEM. Since humanity's first steps on the moon, we've seen how space missions can capture the collective imagination. Today, Mars plays a similar role but with an even greater reach, thanks to social media and instant information dissemination. When children watch rocket launches, follow rovers exploring alien landscapes, or see astronauts training for future missions, they begin to dream of possibilities that once seemed unattainable. These moments plant seeds of curiosity and ambition. A striking example is the Perseverance rover, which has a camera called Mastcam-Z capable of sending stunning images of the Martian surface. These images are shared publicly, allowing students to virtually explore Mars as if they were there. Additionally, educational programs developed in partnership with space agencies encourage young people to actively participate in space exploration. Projects like Name the Rover, which invited students to suggest names for Perseverance, show how it's possible to involve the younger generation directly. Another exciting initiative is the use of simulators and educational games that allow students to experience the challenges of exploring Mars. Tools like the Mars Simulation Toolkit or online interactive learning platforms make complex concepts accessible and fun. These activities not only teach science and technology but also cultivate essential skills like problem-solving, critical thinking, and teamwork, qualities that will be crucial for tackling future challenges. Moreover, Mars exploration highlights the importance of global collaboration. It shows that when we work together, we can achieve extraordinary feats. This sends a powerful message to young people. They can contribute to something bigger than themselves. Many of the scientists and engineers working on space missions today were inspired by events like the moon landing or the launch of pioneering probes. Now, Mars is taking on that role as a catalyst. Private companies like SpaceX are also playing an important role in this inspiration. Elon Musk's bold vision of colonizing Mars sparks enthusiasm among young entrepreneurs and visionaries, showing that seemingly impossible dreams can become reality. However, it's essential to ensure this inspiration is accessible to everyone. Inclusive programs that reach underrepresented communities are crucial to ensuring more young people have the opportunity to engage with STEM. Women, minorities, and people from less developed regions often face barriers in accessing scientific education. Initiatives promoting equality and diversity in the space field help build a more equitable and innovative future. Films, series, and documentaries about Mars also play a crucial role in inspiration. Productions like The Martian and Mars by National Geographic present space exploration engagingly and accessibly, captivating audiences of all ages. Finally, Mars exploration reminds us that the future is not fixed or inevitable. It's shaped by the choices and efforts of each generation. By investing in education and inspiration, we're paving the way for a future where humanity can thrive on other worlds. Mars is not just a distant planet in space. It is a powerful symbol of our dreams, fears, and aspirations as a species. When we look at the red planet, we see reflected our desire to explore, discover, and transcend limits. This challenge goes beyond science. It's a philosophical journey that makes us question who we are and what our place in the universe is. By seeking answers on Mars, we are, in fact, seeking to better understand ourselves. The water on Mars, for example, is not just a physical resource. It's a metaphor for life, adaptability, and resilience. Just as water shapes landscapes and sustains ecosystems, our efforts shape the future of space exploration and humanity. But Mars also reminds us of our fragility. While we dream of colonizing other worlds, we need to take care of the only planet we have today, Earth. After all, what we learn by studying Mars can help us protect our home. The extreme conditions on Mars show us how precious the delicate balance is that sustains life here. Climate change, resource scarcity, and pollution are urgent problems we need to solve before thinking about expanding our presence to other planets. However, Mars also offers us hope. It shows us that even in seemingly inhospitable environments, there's potential for life and renewal. This message is especially important in times of uncertainty and global challenges. Moreover, Mars teaches us the value of collaboration. No single space agency or private company can reach this planet alone. Similarly, humanity's great challenges can only be overcome when we work together. Exploring Mars also inspires us to dream big. It proves that, with determination, creativity, and technology, we can turn seemingly impossible ideas into reality. This is something we can all apply in our own lives. Imagine the impact of a child who, upon watching a live transmission from Mars, decides to become a scientist. Or a young person who, upon learning about space drones, chooses to study engineering. Every small step toward Mars can inspire an entire generation. And you? How can you be part of this journey? Perhaps by following space missions, sharing knowledge with others, or even considering a career in STEM. Every contribution matters. If you're interested in this topic, there are many ways to get involved. Follow space agencies like NASA and ESA on social media, participate in science outreach events, or explore educational platforms offering free courses on astronomy and space exploration. You can also support initiatives promoting equality and diversity in the space field. Together, we can ensure that the future of exploration is accessible to all, regardless of where they were born or their current circumstances. Remember, Mars is not just a destination. It's an invitation to dream big and act now. Whether by inspiring others, learning more, or advocating for a sustainable future, you can make a difference. So, what are you going to do today to embark on this cosmic journey? Share this video with friends who love science, subscribe to the channel to follow more content about space exploration, and leave a comment telling us what fascinates you most about Mars. Together, we can continue to explore the infinite and build a future full of possibilities. Thank you for watching, and until next time,